Hi, Steve Sufflettle here from Erie Community College, south of Buffalo, New York. Recently, we've been speaking with our students about addressability and resolution, whether it be for a image capture on the input, a scanner, digital camera, or for output on a computer display. So we have two Mac labs. Each has 14 Apple iMac computers, so we have a total of 28 computers. And they're the 21.5 inch Retina displays, which are made by either Samsung or LG. And they're brand new computers purchased in 2019, and they're about $1,500 each. They have 1 terabyte of hard drive and 16 gigabytes of RAM. And what I wanted to do was just do some, simple math when it comes to their display resolution. So if you look at the technical specifications, which you can find on Wikipedia and search for Retina Display, it turns out that the Retina Display is 4096 by 2304 pixels. This makes it obviously a 4K device for ultra high definition. So if you take these two dimensions, the width and the height in pixels, and multiply them together, you get over 9.4 million pixels. Now if you take a ruler and you measure the horizontal width, it turns out to be 18 and 11/16 inches, and the vertical height measures 10.5 inches. So if you divide the number of pixels by the dimension, you'll get the resolution in pixels per inch, or PPI. And in this case, it's 219 pixels per inch. Now, I can remember back in the 1980s where the standard display resolutions were only 72 pixels per inch on a Mac and 96 pixels per inch on a PC. And that resolution was called VGA, and it measured 640 by 480. Now, any conversation about resolution and addressability also has to consider the viewing distance. So I think Apple considers the viewing distance for a laptop to be about 20 inches. The next question would be, what is the size of the pixel? So if you take let's do this with our calculator. I don't have access to my calculator here. If you take 1 and divide it by the pixels per inch, which is 219, you'll find out that that's 4.6 thousandths of an inch, which is 0.117 millimeters, which is 120 microns. And of course, a micron is 400 thousandths of an inch, and 1 inch is 25,400 microns. And there's 1,000 microns in a millimeter. Now, just to put this in perspective, if I take 60-pound plain offset paper and measure its thickness, its caliper, it's 4.5 thousandths mil, or points. So that basically means that my screen display resolution is about the same thickness as a piece of 60-pound paper. The other thing we might want to do is take a look at the aspect ratio, or the AR. And by definition, the aspect ratio is the proportion of the width divided by the height. So in the case of 4,000 pixels by 2,000 pixels, it comes out to 1.78 to 1, which is the same thing as a 16 to 9, which by definition makes it a high definition display. Now, we could use some trigonometry, study of triangles, their lengths and their angles, to verify and confirm that the display is 21.5 inches. So as you know, you measure a TV or display on its diagonal, the slant. And of course, it forms a right triangle. It has a square corner. So the Pythagorean theorem states that c squared is equal to a squared plus b squared. So using basic algebra, we can solve for c. So c, the hypotenuse, the diagonal slant, is the square root of a squared plus b squared. So if you did that, you would find out that, again, the screen is 21.5 inches. Now, if you want to use some more advanced trigonometry, you could use the sine, cosine, or tangent to calculate angles. And we've done that too. Now, the sum or the total of the interior angles of a triangle must always add up to 180 degrees. So if you have 180 degrees total, and you know one of the angles is a right triangle, 90 degrees, you're left with 90 between the other two angles. And when we calculate using trigonometry, we find out one of the angles is 60, which means the other angle has to be 30 degrees. And of course, when we talk about the color of the pixels, we know that they're red, green, blue, or RGB. That's the additive primaries. And the iMac uses light emitting diodes, or LEDs, and it supports DCI P3 from 2007 color space, which is about the same size as Adobe RGB from 1999. Now, older display technology used liquid crystal displays, or LCDs, and they work physically as an optical filter, so they subtract light. They're subtractive, so that means you needed to have a white backlight for the system to work. And then finally, if we take a magnifying glass and we look at the pixels on the display, we notice that the subpixels, the red, green, and blue individually, are rectangular, vertical. But when you take those and form the single pixel, they now create a square, and they repeat in RGB. So hopefully this little homework exercise helped us understand some of the concepts of resolution when it comes to a display. Thank you for listening. Have a good day. Bye now.